All right. Okay, welcome everyone tonight here to EthVan. Thanks for making the slippery, slidey trip out here. Appreciate the few faces we do have here today. A little smaller crowd, but hoping there's a whole bunch out listening in, watching in from YouTube, Twitch, and Twitter, or X, formerly known as Twitter. But yeah, so a couple announcements. We've got the Nouns running. Are we doing it Saturday? We're going?
I mean, if the snow melts and there's no ice, we'll see.
Okay, so weather.
Last week it was a bit icy, so I thought I'd cancel it. But if the weather's safe, then yeah.
We'll go. All right. So Saturday, potentially at noon, head over to the Cactus Club in Cole Harbor. Meeting there for a quick 5K run if you're at all interested. You know, want to get that heart rate up for Saturday.
It's a pretty easy run. It's
pretty chill. It's pretty nice. It's a great run. And then you're right around the seawall. It's beautiful. Magnificent. All right. Then next week we've got, so the last night we were supposed to have the Solana meetup. They got postponed just because it was a complete disaster outside. So we're going to have it on Tuesday. So this upcoming Tuesday, Solana 6 to 9. They'll all be here. So if you're interested in, as we'd said last week, Solana Curious, you know, if you're not already in it, come on over or come down for that on Tuesday. Yep. And then Wednesday, I think we've got NFT and coffee and
ZK
study group.
Yep.
Yeah, so that's it. Or what's up?
Just a quick question about coffee and NFTs.
Coffee and NFTs.
Bring a coffee?
You can bring a coffee to the NFT thing, or there will be some very, I think it's like instant coffee that you can make. So I wouldn't advise that, but there's also tea in the back as well. For those that you don't know, there is a massive tea selection that is, you know, it's very, very good quality. So anyhow, you know, when you come to the coffee and NFT thing, you can kind of help them maybe get, you know, some inspired for deeper coffee if you would like. So yes, what up? No, it was here. It was just, we canceled. Yeah, it just canceled. Yeah, so it's going to be here. Last night weather was nuts. So anyway, with no further ado. Oh, and if you haven't been here, there's a PO app at the back. Sorry, I forgot to mint the PO app today here.
That's okay.
I'm sorry, everyone.
That's okay.
Yeah, but there is a decontrol PO app. If you haven't minted that already, go tap your phone on the PO app device at the back, and it'll indicate that you've been here during winter of 24. But alrighty, Owen, I'll let you take it away.
Cool. All right.
Oh, and if you have questions, make sure you put up your hand, get a microphone, because we are live streaming, and we'll keep an eye on some of the questions and questions that come in. Hopefully, we can answer for people live. I'll keep an eye on that. Alrighty, take it away.
Yeah, I'm here to talk to you on this Thursday. Just as an overview of the space too, we do this every Thursday. It's a great place to kind of talk about different things in Ethereum, technical, non-technical, or even just blockchain in general. So this week I will be talking about kind of the next upgrade for Ethereum. So it's kind of expected to be live in Q1, but there's a lot of things that are kind of a little bit harder to understand. So I'm going to try and break it down and go over all of the different updates. So it's called the Denkun. It's it was supposed to be Cancun and Denab, I think, but they've kind of put those together. But the main thing is Proto-Danksharding. It's a weird term, but I'll kind of explain what that means. And the big part of it is that layer 2s get to benefit a lot. So we'll kind of look at that. So I'll start off kind of describe what Proto-Danksharding is and what other parts of this upgrade are, and then go further into that as we go on and see kind of what the future is after this update. So what's all included? So our main, as I said, part of this upgrade is Proto-Danksharding. It's called EIP 4844. And what this does is it creates a new type of transaction that has, it's specified as a blob carrying transaction. So it has a new type of data storage. And it's not necessarily accessible, but it's verifiable. We'll talk more about that. But it's a new type of data storage on the blockchain. There's also some other things. There's transient storage. It's also another type of storage. It's more so for developers, they can kind of optimize their code a bit more. There's also 4788. It adds commits to each block. So this is kind of a little bit harder to understand, but essentially what it does is lets you create trustless bridges, light clients, better staking pools and like restaking, different things like that. And then there's some other EVM updates, just memory copy, and then removing the self-destruct. But essentially the biggest part of this is Proto-Danksharding, and it will have the biggest impact, and it's very, very, very good for the future. So what is Proto-Danksharding? As I said, it's a new transaction type. We have these blob carrying transactions, and they can carry a lot of data. So often, in general, data is very expensive on a blockchain, and you also have data growth. So over time, if everybody relies on this blockchain and then posting data to this blockchain, and essentially then you get to this point where, oh, a node, to run a node, you have to have 10 terabytes of storage or whatever. That's unreasonable. So this is a new type of data storage, but not the full data is to be stored on the blockchain, just the commitment to that data. So then you can work your way backwards to say, okay, I'm using this data, and this is the commitment of that data, but it doesn't take up as much storage. It's like compressing it and putting it on the blockchain. And it's designed for rollups. So rollups, right now they use call data. Call data is expensive. It stays forever. It keeps getting posted. It gets more expensive. And then, but this transaction data doesn't need to necessarily be stored in call data, so it can use this blob carrying transaction type. So L2s get to benefit mainly from this new data type. But what is this difference? So essentially, call data is pretty standard. It's stored forever. You can access the full data, but it's expensive. And blobs, instead of storing that data forever, they're kind of discarded after some time. And only the commitment is available to that data, which allows you to work backwards to the full data. But they're much cheaper. And so, yes, so I'll take a little bit of a break there. Essentially, we have these call data is what's used right now, but it's getting very expensive. And as I said, people keep posting, or these L2s are posting all this data. Requirements for nodes are getting larger and larger, and you have to have all the storage costs. There's some other storage solutions that say, okay, storage costs are going to get cheaper. So in 10 years, you can get a 1,000 terabyte hard drive, and it's super cheap, so we don't even care about that. There's different ways to deal with it, but essentially what we do is we only store the data for a little bit of time because we don't need it forever. But there's also that commitment. Like, what is a commitment? Commitment is it's a cryptographic concept, but essentially it's like an imprint of this data. So we can take this original data, create an imprint of it that's a lot smaller, and then in the future, if we want to, say, access the original data, we just have to take that data, do the imprint again, and then we can say that it matches what's on chain. So we can reconstruct it and check and verify it. This, when you get into ZK, is very helpful because you can do these verifications very easily, but it also just allows you to store a lot of data in a very small way and not have to store the entire data, just the commitment. So, kind of breezing through this. Any questions? I should have paused there in between slides, but if anybody has any questions so far, I'll continue to explain this more. But yeah, do we have another mic? Cool.
Yeah, you talked about the lifetime of those data.
Yes.
So they are only there for some time. So can you give a practical example of that, of the use of such a
yeah.
feature?
So well, actually, the next slides are about that. So I'll get into that. But yeah. So what does this mean? Major L2 fee reduction. Instead of storing this data forever, like I said, only a certain amount of time, becomes way cheaper. So this is a stat. These I'm not super confident in this diagram, but I found it by Into the Block. Essentially, what they're doing is they're taking current gas prices and the statement that it's expected to be 10 times to 100 times cheaper. So what they did was they just took current block prices and then made them 10 times cheaper. But you can still kind of get an idea of what to expect. So like, let's say Optimism is 38 cents, and if you can do that 10 times cheaper, then you're only doing 4 cents a transaction. Much more realistic for everybody. Even with like CK rollups, like everybody was like, oh, okay, this is so much cheaper. If it's still 20 cents to do a transaction, it's not super cheap for if you're doing like a $5 transaction. But if it's 2 cents, that's kind of a different story. I'm going to skip this diagram for now. But to get into what the examples are for like why we don't need this data forever, the main reasons that rollups actually use this data is essentially for fraud proofs. So if somebody creates a malicious transaction and it gets included in the block, you see that and you're like, no, that's not right, and it somehow skipped past the pre-checks. You need that original data to be able to say, hey, this transaction is not correct. Here's my proof, but I can't construct that without the data. So that's why L2s post that call data. However, fraud proofs are only really allowed within like a 2-week window. So you only need that data for 2 weeks. After that, it's kind of accepted. Okay, nobody caught this. All right, it's going to be a correct transaction. Another thing is permissionless withdrawals. So if the L2 goes down, you need that data to be able to prove I had this ETH balance on Optimism. Let me withdraw it on mainnet. Optimism is down, but I can still exit. You also need that full data to be able to do this. However, you don't necessarily need it forever because if Optimism goes down, you probably want to take your money off pretty soon, and there's not going to be any state updates. So those two, fraud proofs, withdrawals, and the last one is state recovery. Let's say everything gets wiped and Optimism goes down and it wants to, or Optimism or any other L2, and they want to recreate the state. For some L2s, you need to be able to have access for the full data in order to get back to that state. And so you may want that state at some point in case it gets lost. So those are the 3 reasons. However, in most of those cases, like you don't need data forever. We only need the most recent, like last week's data or whatever. And you have that time window where it's still available. And so yes, don't blobs disappear. They're only really needed for a short time. L2s only need this data for fraud proofs, permissions withdrawals, and state recovery. And so with this spec, there is supposed to be about 18 days that this data would stay. This can obviously change, but there is a certain amount of time that it would be enforced. But yes, since you only need it for max 2 weeks, 18 days is totally fine. The other thing to mention is that like nobody's stopping you from not storing this data. It's just we need this data accessible to everybody. But if I want to, I can run a quote-unquote full node and keep downloading this data and treat it as call data as it was before. But there's nobody enforcing the upkeep of that data, making sure it stays. Nobody deletes it. So I'm gonna pause there again. Kind of breezing through this, but any additional questions on what I've talked about so far or in general?
So just a quick one. When you were on that chart with like Optimism, Arbitrum, everybody there,
Yes.
now it was my understanding from a lot of ways that, Optimism and Arbitrum should be in similar costs. However, like latest transactions that I've tried on Arbitrum versus Optimism, like generally Optimism being something like 38 cents, I would be paying like $3 and some odd cents on Arbitrum. So I'm just kind of curious if you can, because like L2 fees is going to show you this. It's going to say the same thing. But when you actually go to a DEX and perform that swap, it is a very different looking landscape. And so that's where I'm like curious where they're getting this data from, if you know this, and why we're seeing that. Because
for L2 fees or
yeah, so like for example here, like so this is saying to send, but like to swap tokens, for example, 36 cents on Arbitrum, where it's 17 cents on Optimism. But I can almost guarantee that it's going to be more like $3 and some odd cents on Arbitrum.
This may just be the base fee.
Okay, and then it's not actually charging the rest of the gas. And so like it just to me this is like a little misleading for most people is what I'm kind of getting at, because it seems like it should be cheap and yada yada, but like when I Mike. No, but like I've done it here. You can just ask the question. Yeah, here we go.
I mean, like L2Beat is pulling directly like from the source, right?
Yep.
So perhaps it's just that if I understand correctly, Arbitrum has more daily users than Optimism. So maybe when you're checking it, it just happens to be like a lot of congestion on Arbitrum and not Optimism at that moment.
Yeah, so I looked on, like I was actually
time?
doing a test on Uniswap because I was like, okay, so I'm seeing the price right now to pay on Optimism, click through my wallet all the way to the end to like see this is like how much gas I'm going to be used. Went over to Arbitrum like seconds later. I even went back and forth.
Yeah,
like
it
I
could also
literally
just be your wallet that's recommending a higher price.
Well, but like is MetaMask or Rabby, or are they actually promoting like a 10% or like almost 10x increase on using Arbitrum?
They give you suggestions like based on current usage, I believe. Like just like you can go in and change that. So I would like what that would make me want to do is then go and check at that moment the usage of Arbitrum versus Optimism. How many people are fighting for the same block space, right? Because it might just be that at that given moment, Arbitrum is just much more used than Optimism is.
Anyways, and maybe that's just the case, is that I'm having a really shitty run of bad luck that every time I check Arbitrum, it seems to be 10x the price of Optimism. But
I'm not
but
sure.
I don't know if anybody else can attest to this or what they're saying. We've got another individual.
Does Arbitrum have live fraud proofs right now?
Okay.
Arbitrum does, I think.
Yeah,
Optimism
they do.
doesn't.
So that also could be a component of the cost, right? Like Optimism doesn't even have fraud proofs live. So like that's not even baked into the fees because they're not taking any money to do that, the whole operation.
Right, but what we're saying is that the fees on L2Beat
and everywhere else, everybody's trying to promote that it's like, it's very similar in cost. And here, when we look at this number, like the difference between 13 cents and 9 cents, like I don't care about that.
Well,
but
L2Beat should be like it's
should be
pulling directly from the source.
Yeah,
like
it should be. But I'm like, where is the
open.
confusion here? Because like the user, I know I'm kind of going off track here from Dankshard, but at the end of the day, like I'm expecting, now my swap's going from 13 cents as compared to like what L2Beat's saying.
Check it right now. Go check it right now. Let's see. Go check it now.
I'll pull out my computer and I'm going to do a test.
Let's
I'll let you carry on, and then I'm going to take a look.
We can work through it.
Here we go.
We can work through it. I have a question.
Yes.
It's not about this. I was just wondering, for Proto-Danksharding, so after Dankun, are they planning to...
Pull the mic closer.
What? Delete the blobs, or is that going to be something they're going to like experiment with only after like real... Like, are they actually going to do that right away?
Yeah, I would expect they would. It's just that the data won't be sharded yet, so there's less space. Yeah. Okay. So when? Soon. It's expected like Q1, but with these distributed teams and everything going on, it's kind of hard to make these promises. However, yesterday did go live on Goerli, so we're on a testnet. And Reth also supports it, so a large, very popular new client written in Rust is also ready. I don't know if they've tried it on Goerli yet. I'm sure somebody has. And yes, so went live yesterday on Goerli. I'm not sure what to expect for mainnet. There's definitely going to be a lot of tests and pre-checks yet. However, it's a good sign we're live somewhere, so we'll be there soon. This, however, like as mentioned previously, this is kind of not the full plan for Ethereum. There's much bigger plan, which is full Danksharding, where the data is not only there's right now with Proto-Danksharding, the full data is stored in these blobs. However, with a sharding implementation, you don't even need to store the full data across all nodes. So you can shard the data and have a much larger block space. So right now, or when Proto-Danksharding goes live, we should have about 0.375 megabytes per block. This is probably fine for a majority of L2s, but it's still kind of limited. Once we have a full sharding implementation, we will have access to like 16 megabytes per block, which is tons of data space. And so L2s can, it's even more, like even cheaper to operate. And so that could be even like a 100x improvement over current prices. I'm not sure what the estimate is there. We still need an implementation for sharding, but what this upgrade does is it essentially does all of the infrastructure required to implement sharding. So EIP 4844, we have these data blobs, this transaction type. All these L2s can come along, and now that we have this spec ready, they can update. And when full sharding comes live, they don't have to do anything else. They have all the infrastructure in place. Once this update goes live, essentially fees just get cheaper and we're good to go. There are some alternatives. So what I've been talking about is considered data availability. You may have heard this concept a lot. But we need some sort of solution for a decentralized data availability. And so there are some alternatives alternative proposals. We could like reduce the call data, or we could offload it to another network. And so these are becoming very popular now. If you've heard of Celestia, EigenDA, Polygon also has a Polygon Avail, I think. But essentially it's taking that storage requirement and just moving it to another network. You can probably get cheaper, maybe it's not as decentralized. There's different trade-offs. But if you do this, you don't necessarily get that access to full sharding in the future. You would have to then upgrade again. And so with EIP 4844, you just kind of have this infrastructure. You update once and you're good to go. But another thing to kind of add in here, this data availability term is not necessarily the best description for what the problem is. It's more so data publishing, because this data is not available even with Celestia or EigenDA. It's not available forever, as far as I know. They don't incentivize storing it forever. So it's kind of better to call it data publishing. You only need to publish it for a certain amount of time, and then it's expected to not be as accessible. And yes, so to continue there on why EIP 4844, rollups only need to upgrade this once, and then they get to benefit in the future once sharding is available as well. But we are still waiting on data sampling implementation. So get to, hopefully somebody comes up with something. I don't know myself like what the status is on that, but there's a bunch of problems there to figure out.
If I understand, I mean, I think what's valuable about other networks like Celestia, right, is that like they can just look to all the work Celestia has done and then like take that and iterate and optimize it for Ethereum, which is, I like kind of like that thesis that a lot of like the really cool developments that happen in other networks, like Ethereum could just like cannibalize, and I imagine something similar will happen.
Right.
Although
so
I haven't been following the DNS stuff for them, for Ethereum.
Yes. So what you mean is like, or what you're saying is essentially, because this is an open source world, Celestia can come up with these implementations and maybe Ethereum takes them and uses them, or we offload that to Celestia as well.
No, I mean, Well, yeah, you can offload data to Celestia. Like that's an option that you were discussing, but I meant more so like for implementing data availability sampling into Ethereum. Like, you know, it's all positive sum, right? All open source code. As long as you attribute it to Celestia, you can make those modifications as you wish. And so that's kind of the beauty of like the modular ecosystem, that you can like, you know, benefit each other and like contribute to each other's code bases. But I do feel like a lot of other code bases get cannibalized by Ethereum being like the network biggest network effects. And so it's just it's good for like Celestia's work is good for Ethereum.
Cool. And yeah, I mean that was pretty fast. I feel like, but essentially that was all I wanted to talk about. Of course, if you have any questions, I'm happy to answer. All of the links and tweets and everything and my contact is on that QR code. Also these slides. So scan it, save it, and you'll be able to access anything. Yeah. Any questions out there? Or on
And
the
just
screen?
before questions, I will report, I just looked on,
Yes. Oh yes.
and I must have been extremely unlucky in every other time that I have checked it, because now it looked like it was, you know, just on Uniswap, because even just like the quoting part too, I was getting 28 cents versus like 18 cents or something. So like that's cool. Like I don't mind that extra discrepancy for, you know, if we're what is it, the fraud proofs? That's what's causing more with Arbitrum, which is fine. Like I've always thought Arbitrum was allegedly more secure or robust or something, but anyways,
They're
so that's
all still
better.
a
And then
work
we can
in progress.
and even if we can just cut it by half, like just a 2x, like that would be a huge increase. But anyway, okay, questions.
Yeah, just a quick question. Just, you know, obviously with like the change from proof of work to proof of stake for Ethereum, that was like a huge change to environmental factors with like energy. I'm just curious if there's any sort of like energy output that's less with this, or
not noticeably as far as I know. I mean the big benefit going in the future would be less silicon going into like storage, so I don't have to buy a 200 terabyte SSD in the future, and I can just use my 4 terabyte SSD that I've been running my node on or whatever. But as far as like actually energy consumption, probably negligible.
I would just add though that Ethereum's energy consumption at this point is like negligible to begin with. Like running a full node or like, you know, persistent staking is like, I just use like an $80 internet plan. I don't need anything more than that. I don't really have a lot of hardware requirements or anything like that.
Yeah, I think more than just like an environmental impact. I was more so just kind of curious as to like what the energy output, if it would change that in a large scale.
I think it would just change a lot of things, right? Because like once you implement full data availability sampling, then you can have more people running like light resource nodes. So hypothetically, so you want to increase participation for verifiability to as many people as possible. So in theory, like I think it would be negligible, but then you have to consider that you're adding new node types, and like that might take a little bit more, but it's just like probably it's so low to begin with. I don't think it would make a material difference. I think you're correct.
And like with something like on Ethereum, there's a bunch of different clients as well. So maybe if you're running a different client, it's less or it's more efficient, or it's kind of hard to say exactly like how it would impact the network. But
and are there any upgrades that are going to be coming for Ethereum that will change the gas fees for the layer 1, or is that something that can't really be changed?
Yeah.
This for L2s.
It should. But if I understand correctly, I think it should reduce a little bit, right? Because like instead of like right now, like rollups post a lot of data as call data, and it takes up some amount of
it's kind of
bandwidth
up to debate whether it will actually change it. Because like the thing is that all these L2s are currently posting to call data. Call data costs as well, so maybe the fee market adjusts so that we're like it's cheaper. But it's kind of network effects as far as I understand, like how that will actually impact it. I'm actually not too familiar with the roadmap for that aspect. But
I think that eventually there are a variety of optimizations, but they're like, if I don't know, there's an updated roadmap that came out not a couple weeks ago or something. I didn't look at it, but I know that in the far future, like if you make like the canonical EVM instance into like a ZK instance, that should really reduce costs, but that's like super far in the future, and there'll probably be a few other things in between.
Yeah. But essentially, as these L2s get better, you get actual on-ramps, off-ramps, these ecosystems get larger. Why do you really need the mainnet? You just need it for consensus. So, yeah.
Cool. Thank you.
Yeah.
Any other questions? Oh, we got one here. Pass it down.
So with sharding, the data is getting split. Is that correct?
I don't know if I can really answer that. But essentially, from what I understand is that, yes, data would not need to be stored in full. It can be distributed more, and then accessed from multiple. Do you know more?
Yeah, it's like some really fancy math, but the way, so basically it's like this thing called data availability sampling, where like, how do I explain this? Like remember I told you how there's going to be new node types? And so these new node types can be like anyone on your phone or whatever, and like all the job is to sample. So there will be full nodes that require to have the whole state to have everything. But these like lighter nodes can then sample the full nodes, and like, if they're going to sample random pieces of blocks, okay? And so once you get like enough samples, there's a super high probability chance that the data is available by these like full nodes. So it's like not everybody has to hold the data, but like fewer people can, but you have more people verifying that and not actually holding it themselves. It's quite that's a whole presentation in of itself.
So Avalanche kind of does this already. I know Steph loves this, but it's essentially like it's not the same, but the idea is that there's so many people testing random points of it. Say I know a full sentence, and a bunch of different people are testing different letters of that sentence at different times, to where there's so many people validating that there's an A here and there's a D here, that because there's so many different people validating different points, even though they don't know the full sentence, we know that everyone agrees that each letter is in each spot without actually loading the full sentence. Does that kind of make sense?
And when it comes to reconciling the data, how do they do that?
So sorry?
To reconcile the data.
So if you're doing like the commitment and checking, or sorry, are you asking because the commitment is posted, not the full data? How do you reconstruct it, or? Yeah. Okay. So yeah, so if essentially it's very easy to kind of do it in more of a ZK landscape, as far as I understand. But if I need to prove from this full data that a transaction was wrong, okay, I can do all of this off-chain and say this is a wrong transaction, and when I rebuild it with the rest of the data, I get to this commitment, and I can post a proof of that process of reconstructing that data off-chain, and then saying that on-chain this matches this, and part of my computation shows that this was incorrect, or a false transaction, or the malicious transaction. Yeah.
And also talking about what we just said, it's almost the same thing in video compression. When you want to sample an image and compress it, you got to do some sampling. But it's so well done that you don't see the difference between the full quality and the... So it's kind of not the same, but I mean, it helps me to understand the way it works.
Yeah,
I don't know.
I don't think I'm confident enough in my understanding to speak kind of on the data sampling, unfortunately. But I will look through it through the next
Thank
week
you.
and get back to you.
Any other questions? Final questions? I don't think, was there anything from online? Not sure if there was
Any stream queues?
anything that had come in. Don't think so, but all right.
Cool.
Well,
Yeah.
okay, round of applause for Owen. Sweet. All right. Well, thank you, everyone. Don't forget to mint your POAP at the back. And if you don't mind, help fold up some chairs, and we'll just stick them behind the door there with the others. And feel free to stick around for a little while. All righty.
Yeah.
We'll see
Thanks
you all
everyone
next week.
for coming out in the weather. Yeah.